Templates are a powerful feature of C++. One of them is especially powerful: parameter packs. Let me show you all about them. Let's suppose you want to use template parameters, but you don't know upfront how many. That's where parameter packs come in. They allow you to specify an arbitrary number of parameters which can be then processed. Let's see this in practice. Maybe let's create a generic add function which will add arbitrary number of elements of arbitrary types. Let's start with a keyword template, as usual, then class, and here's the new part. 3 dots, and an identifier t. This means there's an arbitrary number of type parameters. 3 dots mean 0 or more, and all of them are collectively named t. We will see soon how to handle all of this. The return time will be auto, the name will be add, and let's take our arguments by value. We say t, then we add 3 dots and the name. This is also something new. This means we have an arbitrary number of arguments, all collectively named args, and each argument corresponds to our template type parameter coming from the pack named t. For example, if there would be, let's say, only 2 parameters, we could write t1 plus t2, t1 args1, t2 args2. And this, in fact, is how our parameter pack is interpreted by the compiler. Let's get back to the pack itself. So in essence, each element here gets matched to each element here. For now, let's leave the body empty. So having this signature, what can we do with it? After all, how can we access those args? What we need to do is to expand the pack into something usable. Expansion can take many forms, and in our case we need to use something called fold expressions. These expressions allow reducing packs to a single value using a chosen binary operator. For addition, we will use a simple plus. So we write return. Here we add parentheses. This will tell the compiler we want to create a fold expression. We add 3 dots here. We then specify our operator and the name of our collection of arguments. This here means apply plus operator between all arguments coming from this pack. So if there were, for example, again 2, this would become args1 plus args2. If there were 3, we would have plus args3, etc. The compiler is smart enough to deduce all of this using only 3 dots, an operator, and the name of our pack. Now we can call it with an arbitrary number of arguments and see the results. So let's create our main. Inside, for example, auto_x equals add 1, 2.54, because we can mix types, and for example 70. And that's it. Our add function takes an arbitrary number of arguments. The type of each argument becomes its own type in this pack here, and the value is present here. If you want, we can also tweak the fold expressions a bit. For example, we could add initial values like, for example, 0 plus something. We can change the order, for example, args plus, and 3 dots here. For complete reference, take a look at the link in the description. Another form of expansion is a simple passing of the pack to another place, for example, another function. To show this, let's make our own version of makeUnique, which is present in the standard library, of course. We start by template. We then have one type parameter t, which will describe our result type. We take an arbitrary number of type parameters. We return auto again, make unique, and now we, as before, take arbitrary number of arguments, but we now use our value references, and we name them args. Adding a reference here simply adds a reference before each of the actual argument. And here we simply return std unique pointer of t, new t, and inside let's use perfect forwarding to forward all our arguments. So we use std forward, we say args here, and 3 dots here. Let's see if it works. Make unique int of 32, and it works. What we can see here is that we can apply a function to each of the arguments during expansion. This construct here means apply std forward to each and every one of our arguments, and then forward all of this to the constructor of our t, just like you would do normally using commas. Okay, this is all fine. We know how to use them as simple values. But packs can be expanded not only to such expressions, but also as parameters to another templates. So let's do a bit of metaprogramming and create a compile time sum using such pack. Let's start with a base template. This template will require at least one argument and will recursively compute the sum. So we start with template. Let's simply compute the sum of ints. It will be simpler. So int I, then int rest. Again, this means arbitrary number of constant integers. Then let's call it, for example, sum. And inside, let's have a single static const int value equal to 1 plus sum of the rest value. So we take the first element of our template arguments and we sum it with everything else after the first argument. We'll see this in practice in a minute. Finally, we need to add a specialization which will end our recursion. So template I struct sum of I, and again inside we will have a static const int value which will be simply equal to I. So then we can, for example, compute sums like this. Auto something equals sum 1, 2, 3 value, and here we go. Z is computed in compile time. As you can see, we can call sum with an arbitrary number of ints, and it will just work. So we know now how to deal with template arguments as values. We know how to deal with them as parameters to another template. But what if we want to know the number of the arguments? Such a simple thing, right? We have a new operator just for that. This operator is simply called sizeOf and 3 dots. So now let's create a helper struct which will simply give us the number of our elements in a parameter pack. So we'll start with template. Here we have a parameter pack of some types. Struct size, and inside we will have a static const int value simply equal to size of 3 dots of t, and here you go. This is a simple compile time extraction of the number of actual arguments in a parameter pack. With some imagination, parameter packs become extremely powerful and allow for a lot of advanced metaprogramming tricks. If you dig into the standard library, you will find them all over the place. Okay then, I hope you found this informative, I hope you found this interesting. If you have any questions about parameter packs or anything in general, post them down below, keep subscribed, click thumbs up, and I'll see you in the next one. Peace!